Dear students, I am S. Harisankar from Sacred Heart School, Rayagada. In my last video on class 10 chemistry, acid, base and salt chapter, you have learnt about acids, its properties and preparations. Now in this video, I would like to explain you about bases and its properties and preparations. Today's the contents are definition of bases with examples, classification of bases, properties of bases, preparation of bases, and some questions with regard to this chapter on bases. Now, what is the definition of bases? A base is either a metallic oxide or metallic hydroxide or ammonium hydroxide which reacts with the hydronium of an acid to give salt and water. For example, copper oxide, magnesium hydroxide, sodium hydroxide, potassium hydroxide, ammonium hydroxide and aluminum hydroxide are some of the examples of bases. Bases which are soluble in water are called alkalis. For example, sodium hydroxide and potassium hydroxide. All alkalis are bases, but all bases are not alkalis because some bases are not soluble in water. All alkalis form hydroxyl ions in aqueous solution as the only negative ions. In case of acids, they form hydronium ions in aqueous solution as the only positive ions. Now here, for example, sodium hydroxide in its aqueous solution gives sodium positive ion and hydroxyl as negative ion. Potassium hydroxide in aqueous solution gives potassium positive ion and hydroxyl as negative ion. Now point number 2, classification of bases. On the basis of their strength, bases are divided into two types. One is strong alkali, the other one is weak alkali. Now, what is a strong alkali? A strong alkali is an alkali that undergoes almost complete dissociation in aqueous solution to produce a high concentration of hydroxyl ions. For example, sodium hydroxide and potassium hydroxide. These hydroxides are highly soluble in water to produce almost highest concentration of hydroxyl ions. All strong alkalis contain almost ions. Now, what is weak alkali? It is an alkali that undergoes only partial dissociation or ionization in aqueous solution to produce a low concentration of hydroxyl ions in the solution. For example, calcium hydroxide and ammonium hydroxide. These two are treated as weak alkalis because they contain ions and molecules. They ionize very less in aqueous solution. On the basis of acidity of base, they are classified into three types. What is acidity of base? Let us know. Acidity of base is defined as the number of hydroxyl ions which can be produced per molecule of the base in the aqueous solution. Now, let us know the three types of acidity of bases. Number 1, monoacidic base. Number 2, diacidic base. Number 3, triacidic base. Now, what is an monoacidic base? Monoacidic base is a base which ionizes in aqueous solution to produce one hydroxyl ion per molecule of the base. The compounds whose acidity of base 1 are sodium hydroxide, potassium hydroxide and ammonium hydroxide. Similarly, diacidic base. It is a base that dissociates in molten state or in aqueous solution to produce two hydroxyl ions per one molecule of that base. For example, calcium hydroxide and copper hydroxide. Here, the acidity of base is 2. Now, triacidic base. What is triacidic base? It is the base that dissociates in aqueous solution to produce 3 hydroxyl ions per molecule of that particular base. For example, aluminium hydroxide and ferric hydroxide. Here are some examples to know the acidity of base of some compounds. Acidity of base sodium hydroxide is 1 because it produces only one hydroxyl ion. Acidity of base ferrous hydroxide is 2 because per one molecule of ferrous hydroxide it produces 2 hydroxyl ions. Acidity of base chromium hydroxide is 3. Acidity of base lead hydroxide is 2. Acidity of weak base ammonium hydroxide is 1. Ammonium hydroxide is the only base whose positive radical is other than a metal. Now, let us know physical and chemical properties of bases. What are physical properties of bases? Bases have a sharp and bitter taste. They change red litmus paper blue, methyl orange to yellow, and phenolphthalein from colorless to pink. Bases are slippery to touch. They are strong electrolytes. Bases show a mild corrosive action on the skin. Now come to chemical properties of bases. Strong alkalis absorb carbon dioxide from the air to form carbonates. For example, sodium hydroxide with carbon dioxide produces sodium carbonate and water. Potassium hydroxide with carbon dioxide gas produces potassium carbonate and water. Bases neutralize acids to form salt and water. For example, calcium hydroxide with hydrochloric acid gives calcium chloride and water. Ferrous hydroxide with hydrochloric acid gives ferrous chloride and water. Point number 3. When alkalis are warmed with an ammonium salt, ammonia gas is given out. Example, ammonium chloride when treated with sodium hydroxide gives sodium chloride, water and ammonia gas. Similarly, ammonium sulfate with potassium hydroxide gives out potassium sulfate, water and ammonia gas. Point number 4. Alkalis react with certain metallic salt solutions to precipitate insoluble hydroxides. For example, ferric chloride with sodium hydroxide gives sodium chloride and ferric hydroxide. Ferric hydroxide is an insoluble reddish brown precipitate. Now let us come to preparation of bases. When metals react with oxygen, they give a base, or we can say basic oxide. Example, magnesium with oxygen gives magnesium oxide. When active metals like sodium, potassium, calcium react with water separately, they form base and hydrogen gas. For example, calcium reacts with water, produces calcium hydroxide and hydrogen gas. Soluble metallic oxides react with water to give a base. Example, sodium oxide with water gives sodium hydroxide. Similarly, potassium oxide with water gives potassium hydroxide. Aqueous solution of salt reacts with base, precipitate the respective metallic hydroxide by double decomposition method. See this example, copper sulfate when reacts with sodium hydroxide gives copper hydroxide and sodium sulfate. Now next point, when metal sulfides react with oxygen, they form metallic oxides along with sulfur dioxide gas. Let us take an example. Zinc sulfide with oxygen gives zinc oxide and sulfur dioxide gas. Now let me give you some questions with regard to this basis part. Question number 1. What do you understand by an alkali? Give two examples of strong alkali and weak alkali. Question number 2. What is the difference between an alkali and a base? Question number 3. How would you obtain a base from another base? Question number 4. What would you observe when red litmus paper is introduced into a solution of ammonia in water? Question number 5. Define the term neutralization. Question number 6. What happens when blue litmus paper is introduced in sodium hydroxide solution? Question number 7. Name a basic solution which doesn't contain a metallic element. Question number 8. State on what basis does the strength of an alkali depend on? The last question is differentiate between strong acid and weak alkali with suitable example. In my next video on part 3, I will teach you on salt, different types of salts and its preparation. Thank you, dear students.